All right, then. Well, welcome to the Microwave International New Media Arts Festival 2021 Unconference, everyone. The festival's theme this year is Yesterday's Fiction, Today's Reality, which feels especially close to home right now, given the climate crisis that's being highlighted by the ongoing COP26 conference, the COVID pandemic that's affecting the world in ways most of us never imagined experiencing personally, as well as the rise in polarization and, well, authoritarianism around the world. So, it raises questions. What's the point of reading or watching sci-fi stories anymore when we seem to be living out a terrifying dystopia? Can we learn to build a better future through projecting different versions of it with our imagination? Does artificial intelligence spell our doom, or can AI be used for creative, positive outcomes? Well, to explore the theme from different angles, we have three speakers today with us: Alexander Mankowski, Philip Jordan, and Ali Nichran. Now, just a few housekeeping notes before we begin. I will give a quick introduction right before each speaker's presentation. And after all three are done, we'll have some time for a joint discussion session with, including a Q&A with the audience. So now all participants are automatically muted during the meeting. And if you're not muted, please make sure you are muted so there's no disruption. In the Q&A at the end, you can either type your question into the chat box and we'll read them out, or you're also welcome to pose your question to the speakers verbally. If you'd rather do that, then please use the raise the hand function and we will unmute you when it's your turn. Since we have limited time, we ask that each audience member please keep to just one question first and try and keep it concise. And if we have time for second cues, we'll let you all know. And one last note, this meeting is being recorded and the video will be uploaded to the festival's website and social media. So first up, we have Alexander Mankowski to speak with us, whose topic is time to self-reflect. Alexander's early background is in social science, psychology, and philosophy. He then embarked on an AI journey when the field first emerged, before it eventually led him to his current field of work as a futurist that involves working on projections of desirable futures, combining social and technological innovation with avant-garde concepts out of the arts. Alexander is a long-term member of the Ars Electronica Science, Technology and Arts jury and a member of Future/IO, a think tank for exponential innovation and desirable futures. Alexander, please.
Thank you very much. Yeah. Oh, you have disabled screen sharing. You have to enable sharing that I can show my some slides. Because I've made a deck for that. It's now possible? No. So, but I can tell you on the topic what I want to talk about is a kind of reset. We have the pandemic. We have the new experience that we are kind of in a Black Mirror movie life, yeah. And now we have the it's still disabled. Now we have the COP26 and we have disastrous numbers from there, and we have to manage our terror, so to say. Especially if you look at young people, they will receive everything what is now in work. If you have you see the timeline, yeah, from to 2100, that's 80 years. That's one one span of life. And after 2100, it will work perfect. You see a blue picture. Yeah. Okay. Fine. It's I think therefore it is if we have pandemic and climate crisis, both of us, it's time to self-reflect who we are, what we are, what do you want? We as a species, we as individuals, as families, and so on, as groups. Since I'm doing this futurist job now for a while, I have the feeling that there are the ideas there in the futurist space are coming over and over again as the sameness. Yeah, it's kind of boring and kind of what to say, the same wishes all over again. Therefore, we have to think, what are we? If we look back in theory and evolutionists, then I can recommend Lynn Margulis. Lynn Margulis, she was the one woman who developed Darwin's theory of evolution farther, yeah, wider, because the thing with Darwin is that most in a naive sense of view, you will see, okay, you grow horns if you need horns, and then the horn, with the horns, they will survive, something like that. The mutation is the key there, people think. But she said, and she proved it, that it's not mutation, but it's symbiosis. Symbiosis between viruses, bacteria, especially bacteria, and these already functioning organisms would come together, build cells, yeah, like we have human cells. And therefore, that's for the pandemic here. Viruses are not enemies or something. It's a quotation from her that viruses are a part of us, a part of us, a part of life. Yeah. The theory goes that viruses are broken parts of bacteria. Therefore, they fit to our genetic material because we are growing out of bacteria also, and so many, I think a few billions of them living in us and making us enabling food, digestion. Therefore, we are embedded in nature. This one was everybody should remember about these Agent Smith in the Matrix, who told them that we are the virus because we are overgrowing our habitat. Yeah, and they are the cure, these so-called AI. So virus, we are the virus, we are viruses. And Time for Reckoning means this one was a road in Autobahn in Germany, totally empty, yeah, and was so weird an experience. I think you know that also from your different circumstances, that it was a kind of kick in the ass to think about what are we. If you look at the pandemic, what was missing as a futurist, I have to say the left side, all this AI stuff, robots. Nothing was helping there. Yeah, it was in the end feet on the ground. And one thing, the internet backbone, it worked, and the e-commerce worked too. But in the end was common sense and improvisation, ingenuity. The left side, all these Ray Kurzweil stuff, there was very quiet. Yeah. Therefore, restarting. I've made four points there, or four parts. Who are we? How do we think? That's very important. And sense of time. How long does it take to change something, to develop? In the end, what can we do about it? If you look at ourselves, what are we? The U is the smiley and on the top. And if there's psychological research on that, and social sciences, there's research on that. If we are in our state where we are now, everybody, then we think we are. The feeling is we are the most intelligent and most developed, and we are so smart. Yeah, and we were very stupid when we were young, but now we are smart. So we are always on the top. And what is forgotten when we talk about this, that in the middle it should be the small point there. Is first that we are developed as a baby, as in the womb. Yeah, and there's a large iceberg behind it. What we have, we are prepared. We are prepared as a being. Yeah, we have the whole genesis of our species is included in a baby. And when the small baby can breathe the first time, it is for the small baby. It's totally open if it's in a cave 40,000 years ago or in a whatsoever modernistic environment. Yeah, so we have these. It's an easy way, a simple way to do it. As the left part, the being, we have as a being, we need love, interaction, growth, nutrition. We have lust, depression, everything. And the other hand, the culture. Yeah, we have language, and we are learning language. So we are deeply embedded in the past of our species. Yeah, and this is all in us. And if we are now think of ourselves, we do not think about that. Yeah, we are as we are. We forget it. And the meaning, if as a the topics, if you research it on the internet or something, it's phylogenesis. That's the species, development of the species. What is in you? Yeah, what is everything? Why? How can you learn the mother tongue first time so easily, and so on? What's your reaction, and how do you work? How do you working? What are your strategies? That's the old stuff. And the ontogenesis, it's yourself. Yeah, developing from a baby to now the adult, the super smart adult and very perfect being what you are now. But this is not to forget, everything else is in the dark. Symbiogenesis, again, this one is Lynn Margulis when she was young. She called that our nervous system is, she called it microbial consciousness. Yeah, so she did not separate between consciousness, what we are feeling now, yeah, what we are thinking now. She said, in the end, all these components are alive, living beings, yeah, and so living beings, they have goals, they behave, they do stuff, yeah. You can, if you look at say a little spider, an insect, yeah, you can feel empathy with a spider, you know, it's going there and there and there, and or a fly even, it will work there. So she said, in the second quotation here, nothing has been lost without a trace in evolution, and so the microbial mind is still there in us. So we have many minds. That's a key message. It's a bit of a hit for the artificial intelligence freaks, but she explains it this way. And we are the great meteorite means that we are on a self-destruct course. We are the great meteorite which destroyed the dinosaurs. So in the end, this is a picture from Ars Electronica, an artwork. I think it explains it there. We are chimeras. Yeah, we can think we are the human beings as we are now, so perfect and video conferencing and so on. But in us, there are many it's. Yeah, this one is, I think it's not very nice, but I think the artist, I don't know his name or her name, has showed us in our character, not really nice, fragile, and yeah. So chimeras, an example for that. What's the imprint? This one is the savannah. This was the birthplace. Longest time we as a species, we thrived there. And in the savannah, there has a certain temperature. Yeah, it's cold, a little bit colder in the night and a little bit warmer in the day. And what researchers find out in North American, yeah, the Americans, they have their homes, they have thermostats and everything, they have central heating, and they think they do it on their own whim, yeah, like they make the heat and the cold, like they are wishing. It's very individualistic, but what they are matching is the temperature of the savannah. So the hand, yeah, moving the thermostat is 40,000 years old, yeah. It's reaching up out of the past onto your thermostat, and you will move your central heating, your modern central heating, to the temperatures of the past. So that's an important. I think it's a little bit very deep experience. If you think of that, if you like something to eat, a banana maybe or something sweet, then think of who is liking the food. Or who is it? It's not you, maybe it's something from the past, yeah, living in you still. If you are able to read German, you should. I recommend Sabina Spielrein was the first woman in psychoanalytics who has a doctor on that, and was very famous. She was the first to come up with the concept of the death, the drive to death, Todestrieb. And what she experienced, he said that we are dreaming the wisdom of our ancestors. Yeah, our dreams can be reframed, and you will find myths and so on, and you will find dreams. Yeah, she had little young girls, yeah, 13 to 17. They work with them. They couldn't have had these dreams. Yeah, these dreams could only be decoded in relation to old myths these girls never have read about or heard about. That was her thing. Another question is, this was also Ars Electronica, are there limits of our imagination? Yeah, this left one is a mouse network, neural network, very small. And right, the Millennium simulation looks the same because we are maybe not able to create something really new, yeah, to get it, because we have our imagination is maybe limited, yeah, to think of stuff. Others, maybe this is we are what we are in this case. Now I skip this one, and then next part. If I've said these, try to explain that way, like with Margulis, that she thinks about, or has the concept of microbial minds, yeah, very old minds. We have the thermostat, which is regulated by our ancestors, not by ourselves, and stuff like that. So the question arises: how do we think? What's the me? Who is it? Yeah. Everybody can make this self experiments. For example, can you make your mind stop thinking? Yeah. If not, who has the will? Is the question. If you cannot make your mind stop thinking, then it's not your mind, obviously. Yeah. If it's your mind, then you can make it at will, free will. Yeah. And how long? If so, how long? And the opposite. If you can you make your mind start thinking on a topic? Does it obey? If not, who's the master? Yeah, you can try it out. Most people know that in the night they cannot calm down the inner voice, and therefore, who is the you that decides for what reason to think? Yeah, the you. Who is it? Yeah, or is it thinking on its own? If it's thinking on its own, then the question arises: hey, yeah, it's me, or it's me, and I watch myself thinking. Yeah, how many are in my head? Yeah, to do so. If you like to read about that, that's Hannah Arendt. Yeah, Hannah Arendt's very famous, and she has in philosophy. And therefore, if you look at Descartes, I think, therefore I am. There's an error in the sentence, and where's the error? Yeah, the error is that the I in think. If it is thinking and you cannot stop it, then you cannot say I'm thinking. Then it is thinking all the time, and you can watch it thinking, watch yourself thinking like that. So you are many, if you look at that. Try it out. What the neuroscientists now are telling us, here's Christoph Koch, here, consciousness. Yeah, a quote from: your body might harbor several autonomous minds forever isolated, as distant as the dark side of the moon. So even these neuroscientists, they say, okay, these are many things, entities, yeah, working on their own in our mind. And what are we then? Like this one illustration, we are many. And I try to give one solution. If your mind is a kind of a garden, yeah, I think that's a simple way to illustrate it. Look at your mind as a kind of a garden, and you are the gardener. Yeah, you cannot force plants to grow. Yeah, you can look at them and you can plant them and so on, but in the end they grow on their own. Yeah, you can open the garden, or they can close the garden to try that in this way, but in the end, in a time scale, then it will grow according to what you are doing with this garden. Yeah, which plants if you look all the time splatter movies, then you can imagine how your garden look like. Yeah, so don't do it. Look out for things you want to grow in your garden. Yeah, and I think this is a very nice picture for the mind. And so what we can do is a gardening of thoughts. Yeah, that was my conclusion, and try to let stuff in. So I don't look television since 20 years. Yeah, I avoid that. Today it's a norm, I guess, that people don't look television anymore. But that was very helpful, I think. Yeah, so gardening of thoughts, that was my solution. But I think you can develop your own metaphors regarding these things, that we are many in one head, in one mind. Yeah, and we are on this iceberg of evolutionary prefabs, so to say. Yeah, so which are working on us too, like what we like or what we not like. So short. How long does it take? Should be short because it's all in all short. So what you can do also is train your sense of time. I think this is important because as a futurist, you know, we do not have a good sense of time. Our sense of time relies on repeated activities. Like if you drink a cup of coffee, then you know a cup of coffee takes such time, but you cannot repeat 10 years. If you have children and one's first is a baby and then it's 10 years old, and then you don't know what has happened. It's not repeatable. So we do not know what 10 years are. And that's especially important or fruitful, this approach for technology, because technology is developing very slow in the human scale. Yeah, slow. Therefore, you can make in your area of expertise lines like that. For example, this one's here when people say, "Okay, digital is so fast," but the basic programming language is C, and this was invented in 1972. That's not fast at all. Yeah, it's very slow. Yeah, the typical processor, the Intel architecture is 50 years old, nearly 50 years old, no 40 years old. This is ancient. So even CRISPR. So all this stuff is slow. So make a forecast about technology is simple. Yeah, because it's so slow. You can see its first is in research, and it's a good thing to train your sense of time. It's helpful. It takes decades. Social innovation on the other side can be abrupt. You have the fall of the Berlin Wall. That was one evening. Yeah, it was one evening. In one evening, the people stormed the wall, and it was opened up. Yeah, like this. Climate change. Next thing. That's the most dangerous because we do not have this sense of time. Yeah. So also if you let, maybe you have if you memorize something, then it would be helpful if the memory, if it's from your childhood, would be colored maybe in yellow. Yeah. So your mind would then help that this is long ago because it's colored or something, but it's not colored. So our mind is not helpful for sense of time. In this case, climate change, what I said in the beginning, there's only one lifespan now until every simulation crashes, because we cannot simulate that. Simulate these 5-degree target. It's impossible. So a young baby now, a born baby now, will, if it reaches 80 years, hopefully, then we'll get the full package. And now we are on the run to 5 degrees Celsius. Yeah, this is not the upper one, 5 degrees, but in the middle. And we need negative global emissions. We need to get, I think it's 1,000 gigatons of CO2 out of the air. Yeah, 1 gigaton is very many zeros in it. So this is a massive scale. Yeah, it's industrial scale. It's not if you shut down the air conditioning or something. So this is heavy. That's the most heavy. Very few people have a feeling for that. Get in panic. Some do. I can skip that. And how to proceed? Last step. So we have these. Who are we? We are chimeras. That's important because our strategies for what we will do to survive or to thrive. Our strategies are set up in an evolutionary scale. The typical strategies were like the Annalee Nevitt said it: scatter, adapt, and remember. Scatter means you are groups from up to 100 people, 120, and then we were split up and always on the move. Yeah. So typical reaction to the climate crisis is go to Mars. Yeah, on the move. Yeah, move ahead. Yeah, but the planet Earth is round, so there's no place to move ahead, despite Mars. And we have to develop our inner older selves. Yeah, and some of them are helpful, some of them are not. Yeah, the scatter is in the moving part is not helpful. Yeah, the adapt part is medium helpful. We have to innovate and we have to change. That's something else. Remember is the thing that we have to tell stories. I think this is very important regarding the crisis, that we have to invent new stories. And how do we think? We have to curate, like the gardener, our thought processes and train them a bit, yeah, or curate them to make it better, because everything is so slow. Yeah, so slow means if we have these 80 years, yeah, 80 years are not much, yeah, technological wise. How to proceed? First thing is learn from evolution. It is not that Darwin style mutation, yeah, grow horns and something, or learn to swim in the water like a fish. It's symbiosis. We have to bridge existing functionality. Yeah, we have to contribute with our talent. We stop quarrel about leadership. It's about it's in the end a collective approach with combining different talents. Yeah, so we have to develop our individual talents and bring them together to solve this part of the future. That's one thing. And the other thing is this unlearn from evolution. We cannot scatter anymore. Yeah, what I said, this urge to mass is misleading. We cannot run away. Yeah, there is no space. And we have to adapt again. Adapt again means we have to innovate and we have to change our behavior, and we have to do that on a grand scale. Last thing I want to, last hint is, yeah, solve the Fermi Paradox. You know, maybe the Fermi Paradox. Fermi was a very famous nuclear scientist, inventor of the commercial nuclear reactors and of the hydrogen bomb and stuff like that. And in the 60s, or no, it was in the 80s, I think. Then the question comes up: where is anybody? Yeah, everybody. No aliens. Yeah, nothing. We are alone. Impossible. Yeah, it's statistically impossible. And the Fermi Paradox then was, why tell me the reason why there is no other civilization, no traces, no nothing. Yeah, there must be a reason. And one reason is that all the technological driven civilizations hit the wall sometimes because of their technology. But I think we should solve it in a different way, and therefore I thank you for listening. And yeah, I'm happy to listen to the other speakers and wait for the discussion.
Great. Thank you so much, Alexander. Just a quick note for everyone who joined later, we will be having a Q&A session after all three presentations. So next we have Philip Jordan to speak on science fiction media, popular culture and real-world technological change, a symbiotic relationship. Phil has a PhD in communication and information sciences, specializing in human-computer interaction, or HCI, communication theories, and social informatics. His research interests include the use of science fiction for computer science and HCI research and education, design ethics, monetization of play and agency in online games, as well as the design and evaluation of HCI and ICT, that is info and communications technology, for special target audiences. Phil is an expert in the area of UX, or user experience, best practices, HCI research methodologies, interaction design, and accessibility studies. All right, all yours, Phil.
Hi, thank you for this very detailed introduction. Is this working? Okay, all right. Cool. So yeah, welcome everybody. My talk is titled Science Fiction Media, Popular Culture, and Real-World Technological Change, a Symbiotic Relationship. I'll present the talk across three distinct sections. I'll look a little bit at the past, create a foundation so everybody's on the same page what we talk about. Then I'll go into more contemporary examples where science fiction and real-world science kind of like collide, show like analogies, and then I'll look a little bit into the future. So let's start with like past intersections. look into the history of science fiction, where it came from. This is maybe like the most complicated slide I have, but it's a really nice visualization of the history of science fiction. And I gotta be honest, if you try to look up the history of science fiction, it's like a rabbit hole. Like you can go back like centuries, millennia, and it's kind of like unclear when one like train of thought started and like what the precise definition is of science fiction. I spent like quite some time digging into that, but this really visualizes nicely how things are. So I just like try to highlight a few things. If you start here on the top left, you can see we talk about things like fear and wonder of like humanity, and we have maybe different like strands of thought. There's some philosophy, social criticism, art. At some point, like there is the Enlightenment, and then maybe like literary science fiction begins to some degree. So we have discrete like subsections here, like the Gothic novel. We have like horror, sword and sorcery, which is branching away, right? Because that becomes fantasy eventually. Similarly, we have here like crime and mystery on the bottom, Westerns. And we also at some point later on have this distinction between like soft and hard science fiction. And it's commonly understood that hard science fiction is the one with the highest degree of scientific veracity. It's highly accurate, right? It's almost like, you know, not fiction anymore. And what I will talk about mostly in my talk today is about this large area of this animal, which depicts the history of science fiction, which is film. Because I truly believe that film or visualizations of the future have like a unique value proposition to all of us. And this is like a piece of art from an artist called Ward Shelley. I have the source on the right, and I just wanted to mention that. So I already like teased a little bit that I focus on science fiction film in this presentation, also like in my studies to a large degree, and just trying to make a point why I do so, which is that obviously it's a trade-off. We all can read about like, you know, Jules Verne, 20,000 Miles Under the Sea, and we imagine in our heads how the submarine will look like, or we might watch a movie and we'll have an idea. So one is like, you know, limiting the imagination of the film, but on the other side, it allows a proposition, a design prop, right? We can look at, we can like see in context, we can discuss about. So the writer has this quote from Johnson. He says, the writer can imagine the novelties inventions of the future several decades in advance and write them down, right? But he can give them only a poetic, so-called existence. Whereas the filmmaker is less fortunate. He must show the invention, the made-up invention, right? And he must show it working to some degree in some context for like a few seconds in the movie or in the show. So a couple of more like details on like building up this introduction to like science fiction film. So there's like film theory, and there are like ways to instill realism in science fiction movies and shows and film. One of them is like via concepts of so-called referential and perceptual realities. And I'll talk about them in a second. They come from Stephen Prince, who wrote this paper you see on the left, and just to quote like an interesting piece, as we will see, even unreal images can be perceptually, like visually realistic. And unreal images are defined as these which are referentially fictional. So that's kind of like a mind breaker, but we'll have an example to clarify. So on the right, we see like a couple of scenes from Jurassic Park, I think, here in Jurassic World. And it's fair to say that none of us here living today has seen like an alive T-Rex or velociraptor dinosaur, right? But CGI allows to computer-generated imagery, right? Special effects allows to some degree, even though we don't have a reference, nobody has seen a dinosaur alive, to create like a version of a dinosaur via technology, which, you know, might be perceived as real. This could be real. This T-Rex here, yeah, this could have been like a T-Rex would have looked like maybe, even though we don't have a reference. So that's an example of like perceptual reality, even though there is no reference. On the left, I chose the hoverboard from Back into the Future. It's an older science fiction movie. The more mature folks might like remember it. And I actually like named this as a referential reality example, even though nobody has seen a hoverboard, right? We don't have a hoverboard, or we kind of have one at this point, but we all know skateboards, right? And these are like tricks filmmakers use. So there is to some degree of reference. We see the board. We just have to imagine the wheels, right? And then this all makes sense. So there's some referential reality here, even though we don't have a reference to a hoverboard, but we all refer to skateboards, right? And of course, there's also some CGI for some perceptual reality. So these are examples we can create perceived realism for the audience in science fiction media, which, you know, a large part of the world, the developed world, consumes. Now to go into more concrete crossings of science fiction media and real world innovations. This is a never-ending list. First of all, so these are just like a few selected examples. A very popular example is the flip phone, inspired like by evidence from an inventor called Martin Cooper, who referred to Star Trek, like Captain Kirk, communicator, kind of like inspiring him to develop this device, right? He wanted to walk around and not be like bound by a telephone cord. Also, Star Trek had this other flip device. At some point, it wasn't flip anymore. It's a medical tricorder, like a portable device to scan an injured person, for example. And the X Prize Foundation actually did like a award a prize for like research teams across the globe to develop this medical tricorder, and there are like two types of research teams who like developed such a device, a portable device to diagnose, forgive me, I don't recall, 10 or 12 common conditions. More examples are like foldable interfaces for handhelds, and not all of them have been inspired from science fiction, or vice versa. This is merely to show like crossings and overlaps. So here you see like foldable phones and Westward interfaces, cleaning robots as depicted in The Fifth Element. And this is like a so-called needle table, which was developed by the military in the United States from an engineer after he saw an X-Men movie. And this was being actually used like in the field. So this is kind of a table which can like shape the terrain, and then like a landscape is projected on the top of it. So military squad could like, you know, gauge a little bit of terrain and plan the mission. That is based on this science fiction scene where like they try to defend the city against an attack from the supervillains in the X-Men movie. Of course, this is also not only about the devices, interactions. This is also science fiction, as you all know, also like social critique to a large degree. Also has often like political connotations. So a good example which comes to mind to exemplify that is Black Mirror, great show, which I'm sure some of you have seen, which visualizes many like dystopian social constructs and potential developments. And here I put next to each other social credit system in China, which is very much similar at a glance. I know there are like differences if you look closer to a specific Black Mirror episode called Nosedive, which depicts a person who also lives in this future society, which has like a ranking of some sort and gets penalties if there is certain misbehavior observed, right? So if you behave well, you get access to more services, you get better treatment. Accordingly, if you behave like worse, you lose access to certain perks. So to close out my first part of this talk, try to show that a little bit, right? That science fiction, especially like the visual science fiction, can be quite powerful in terms of showcasing innovative, questionable, or controversial futures. And that's just a statement as is. So taking that, now we can see what we do with that next. So now I'm going to go into some more recent overlaps between real-world science and science fiction media. I'm going to start off with just a couple of resources which I found in my research and studies, which tackle that topic. So there's a website which is called Sci-Fi Interfaces. You can go there right now. I'm not affiliated, I'm not promoting it. But the curators of that website have also written a book which is called Make It So. And that website is really nice because it shows a range of interfaces and interactions as seen in science fiction film, and just analyzes them if they have actual value or reality. So they look, for example, here on the bottom left, you can see they analyze some chess panels as being placed on spacesuits in movies. And they have some HCI, human-computer interaction background. So they discuss these devices from an interaction usability point of view, which is quite interesting, especially for me. Now, going away from the devices, let's talk about something larger. Can we find inspiration for future robots, for example? Well, this is a nice example I have for you here. On the left, we see Baymax, which is this big, white robot here in the center from the movie Big Hero 6. I think it's a Disney animated movie. And in a 2017 paper, researchers from Italy have developed Puffy, which you see here on the right. And Puffy pretty much embodies the visual appearance of Baymax of that movie. And before I say a little bit more about Puffy, I'm going to show you just a video excerpt so you have a feeling of how this robot looks like in real life. And I hope I can make this work. See, yes, like this. So this is an excerpt of Puffy, and I can tell a brief story. So I was looking at the research paper, and the researcher introduced Puffy, and they mentioned Baymax from Big Hero 6. And they said the visual appearance, the embodiment of the robot came from that movie. But some of my fellow researchers were actually meeting them at a conference in person, the authors. And they mentioned to them verbally that basically they went to see that movie and that inspired the whole research project. So without Big Hero 6, the movie, that wouldn't be Puffy. It was not only about the visual aesthetics. It was the whole idea to have this cuddly, loving, nice robot and put it into a context for children, which I found really interesting, because in the research paper they clearly just use one sentence to refer to that movie, that science fiction artifact, as yes, we took the visuals from that movie, but the idea kind of was our own. But they agreed, or they mentioned that it was really inspired by the movie. So moving forward, how about a sci-fi inspired interface? So this is an example of a memory orb, which is this device you see there on the left, designed by Mike Hill for the movie Blade Runner 2049, which is obviously a remake of the original Blade Runner from the 80s with Harrison Ford. So kind of has a cylindrical shape, and it's multiple buttons. You can expand it, you can compress it, you can turn it. And in Blade Runner 2049, the scientist here uses it to create memories in a virtual reality, simply said. So I was being recently approached by a PhD postdoc from Finland who decided to create the memory orb excuse me, as a prototype, right? He wanted to like build that device. He saw the movie. It's an interesting device, has interesting like shape and like input affordances. So we just did that. He did that, and I helped a little bit with publishing the results and writing the paper. So there you can see like the exploded view of the memory orb on the top. You can see the actual device on the bottom left, and also then the corresponding VR experience. So this paper is in print right now. It's going to come out in a week or two. Also for this memory orb, I have a little demo. So here you can see one of the functionalities, spanning the cylinder and like zooming in, turning, moving the VR image. Cool. Now let's continue this line of questioning. How about sci-fi inspired life? And I'm not like insinuating I'm saying yes or no to my own questions here. I'm just like putting out examples to create a discussion. Right? Quite recently, was it like a week ago, Facebook got rebranded to Meta, or the mother company, I guess. And from the founder's letter of Mark Zuckerberg, there's a quote, which I'm going to read out. So among other things, he like positions Meta now, the mother company, and describes the Metaverse, right? The main concept of that as an embodied internet, where you're in the experience, not just looking at it. Yeah, that sounds fancy. Furthermore, he says, in the Metaverse, you'll be able to do almost anything you can imagine. Get together with friends and family, work, learn, play, shop, create, as well as completely new experiences that don't really fit how we think about computers or phones today. And one can't help to look at science fiction, which actually coined the term, Neil Stephenson, like 30 years ago, talking about, you know, in the metaverse, you can have a double date, finding down at Port Zero, which is the local port of entry and monorail stop, Fiction City. The people are pieces of software called avatars. They are the audiovisual bodies that people use to communicate with each other in the metaverse. So you can't deny there's a certain link. I don't know if Mark Zuckerberg like read that book or was inspired by Stevenson, but certainly like the metaverse was described, not visualized, but described 30 years ago. My last little question in this part of the talk is how about sci-fi inspired science? And this was the topic which I engaged with during my dissertation research for my PhD. So I saw all these like individual examples. Some of them I showed you, right? These case studies, the anecdotal evidence, and I wanted to know like, hey, can I find real evidence that science fiction, you know, plays a role in technological development? And if so, can be exploited for the better or the worse for like, you know, the future innovations. So what I did in order to do that on a scale is, instead of looking at individual cases or conducting interviews with science fiction authors or researchers, all of which I could have done, I decided to research computer science communication, because that was quite easy to do on a scale, right? We talk about, I was looking at research papers, research output. And I'm just going to present like a couple of results of my body of research for simplicity reasons, just to give a glimpse of what I found with regards to the question, how do scientists use science fiction in their research output? So this is a study I conducted in the IEEE. That's the largest institution for electronics engineers, as far as I know. They have this so-called IEEE Explore Digital Library, which indexes all their research outputs. And I did look for papers who talk about science fiction. And I did retrieve randomly selected 500 publications. There were more. There were about 2,000, I think, in the whole database, but I couldn't look at all of them, so I looked at 500. On the top right here, you see an image which shows research paper types. So the literature gives you different research paper types. And I try to look at what research papers, what classes of papers look at science fiction. So one result I want to point out here is you can see that from 500 papers, 153, and that's more than 30%, were opinionated pieces. So they were not really research papers. They were more putting out a philosophical argument. Scientists might have written about robots and mentioned somewhere Terminator 2, the science fiction movie, which showed the killer robots, right? So it wasn't really necessarily proposing a new method or an empirical piece. It was opinionated research paper. So that's what I found in that part of the study. What I also found in the bottom right image is that most of the science fiction references come from this group, which I called fostering or driving innovation in the paper. So we have these contextual referrals that was about how is the science fiction being used in context, right? Is it used to discuss an idea which came from science fiction, for example? It's talking about making science fiction reality, or is it even mentioning unreal science fiction? And the vast majority of the referrals I found fell into this category. So it was kind of undeniable that science fiction is used to draw inspiration and innovation in the paper. And overall, I found this reflection of pop culture in which science fiction can be defined as over time and space, because I analyzed papers over 60 or 70 years. So this is a second example of my research, and I'm going to keep it really lightweight here. You can look up my research. It's published on Google Scholar. This was a paper we wrote about science fiction robots. This one was in the ACM digital library. So we looked at science fiction robots as they're being used in the Association of Computing Machinery. It's the largest computing association in the world, in research papers. So we looked at 18 science fiction robots. You can see them on the bottom right here. So we have here Skynet from Terminator, the evil robot. We have Wall-E. We have R2-D2 from Star Wars, Maria from, German science fiction movie, and so on and so forth. And this specific chart looks at the nature of reference, the context. And what you can see here is in green, you see predominantly utopian references, and in red, dystopian references of that specific robot. And I'm going to point out HAL 9000, which all of you know, but is Skynet. It's really interesting, right? So Skynet clearly was an evil robot. Skynet was the main AI, which they tried to destroy in Terminator. It wanted to destroy humanity in turn. And even though I believe these are we find two utopian references to Skynet, a few neutral ones, predominantly dystopian ones, of course, that makes sense. If we look at HAL 9000, it was a very individual case, right? A specific case. HAL was kind of good at the beginning of the movie and then went rogue, right? So there was an evolution of the AI, though we still have more utopian than dystopian references. In any case, overall, we find similarity to the first of the more philosophical papers and technical papers. We find that often the papers talk about voice and dialogue with regards to the science fiction robot as qualities we strive for. And looking at the whole chart on the right, we see a lot of green, right? Especially Wall-E, for example, or Mr. Data from Star Trek. So overall, we find a more utopian presentation of the robots in the scientific literature. Okay, I got a couple of more slides, and that's my presentation. So talking about future opportunities as well as challenges of this topic I just opened up, science fiction, media, which can be books as well, right? Shows, movies can also be games. Interactive media are focused now on the shows and movies, as indicated, and real-world science. Let's start with the good things, the potentials, in my opinion. Clearly, I think that science fiction media is super useful for concepts and areas, research, and contemporary challenges like technology ethics, morality dilemmas, fields of computer science, AI, machine learning, environmentalism, social construction of technology, agency, and so on and forth. To give one example, if we have self-driving cars, who is responsible if there is a car accident and the car failed and some people died? Is it Tesla? Is it the engineer who wrote that piece of code? Is it like a human who trusted the system? We have 100 years and going history of science fiction film. 1895, 92, a French silent movie allegedly is being called the first science fiction movie. So it's quite short history, but there's a large repository of like media, and with like digitalization, it's actually more accessible than ever, right? We have like advancement in like storage capacity, we have like increased broadband access over the globe. So there's this like a cinematic proliferation and this development of CGI. CGI gets only better, right? So this allows us a visualization of how things could be in all kind of areas. And of course, like I tried to show a little bit with focus on HCI, devices, interactions, there's potential for creativity and inspiration. And this also can like, you know, create new methods, which are being pursued right now in the field. Among those, design fiction and science fiction prototype. Okay, coming to the challenges. Obviously, scientific veracity or fundamental truth in science fiction relies heavily and is subjective. So a good example are like the dilithium reactors or the material dilithium in Star Trek. So Star Trek, The Next Generation, is a very utopian science fiction show. Some of you might know it. And the show is based on a bunch of like utopian propositions. Among those, like an abundance of like never-ending energy. They have like anti-matter reactors. And to do so, they just invented like a new material, crystal, which they call dilithium. It doesn't exist. But that like kind of creates the foundation for the whole like premise of the show. So of course, like we have some components of sci-fi which are still made up, right? And we cannot just like, you know, assume that time travel is possible because we want to like pursue like innovation, that reaction, in that direction. It's also important to note that sci-fi often relates to and is impacted by geopolitical developments. Examples are Battle in the Clouds, is an oldest black and white sci-fi movie which depicted like World War I Zeppelin bombing rates. Great example for tragic event are like the Japanese Godzilla, or I think it's called in Japanese Gojira movies, which visualize the aftermath of like Nagasaki and Hiroshima bombings. And Destination Moon is a 1960s US space exploration movie, which was created as a response to like the space race at the time between the Soviet Union and the United States. Third challenge, different medium formats provide different affordances and constraints to the reader, the viewer, or player. So I try to indicate that, right? I said you might have a novel, you can read it, right? And kind of sad. You might be able to see an excerpt of a movie where we can watch an interaction. We see the hoverboard in Back into the Future 2, it's flying around. We might even play a sci-fi game and decide in which way to go with a narrative. And all of these different medium formats have advantages and disadvantages at the same time. And my last challenge I want to like put out there is science fiction terms, the terminology, and the concepts themselves. They change and evolve over time because the technology does, right? So this is something to keep in mind, especially if you do archival historical research. So I know I'm at 30 minutes, so I'm going to wrap it up. In conclusion, science fiction reimagines and science reinvents itself in an ever-evolving symbiosis of both fields across time, space, medium, culture, politics, and zeitgeist. As I tried to show you, there are clear links and influences between art and science. And in my humble opinion, the potentials clearly outweigh the challenges. So among other things, I do advocate to integrate sci-fi, pop culture, and media systematically into STEM. That's science, technology, engineering, and mathematics, education, and research, to foster creativity, to create ethical discourse, and to showcase possible alternative futures we are creating, whether intentionally or not. So that's my talk. I want to thank you very much. And you can always reach out to me via that email after the presentation today. I'm always happy to chat and collaborate. Thank you.
Thank you so much, Phil. Now we're on to our third and final speaker today, Ali Nichran, who is a researcher and artist at the Ars Electronica Future Lab in Linz, Austria. He has a background in technology and art, as well as music performance and composition. His research centers around the interaction between human and AI systems for creative tasks with a focus on music. He is the creator of the software Ritika, an AI-based collaborative music composition system for classical music. In 2020, he received the Young Researcher Award of the Upper Austria Council for Research and Technology for his research in the field of AI and music. Ali will be talking to us about AI creativity in the light of arts and music. Ali?
Thank you very much. Can you hear me now? Can you hear me?
Yes, we can.
Okay, perfect. Thank you very much. Yes, so the topic here is about creativity from AI, as it was mentioned. And it is the focus is in the light of music and arts. But first of all, before we start, the question is, we are talking obviously about creative applications of AI. And we all know that creativity is a very, very human ability. So creative ideas just come in our mind. We are not able to explain where they come from. And creative ideas are also somehow they are created in a very personal manners, because they are just created in our mind in isolation from others, and we don't really know how they are suddenly like a flash created in our minds. So during this presentation, we try to discuss these questions, these issues, and these problems that we have with AI and creativity, and we will try to address this and to find solutions for this. So I can skip this slide already because it was mentioned before. So in this presentation, I will talk, first of all, I will talk about creativity from three different perspectives. A human perspective, which is about how can we define creativity, human creativity, of course, in that case, and also about AI creativity. So it is more a technical discussion, how is creativity implemented in AI systems. And we will also discuss artistic creativity. What's the difference between artistic creativity and the general daily life creativity, so to speak. And I will also argue, actually this is the message of this talk, I will argue that AI creativity is more about exploration than creation, mainly because of the lack of human intention, and because of the autonomous and non-explainable nature of modern AI systems. So first of all, let's start with the definition of creativity. Of course, there are many definitions of creativity, but one of them that is commonly used comes from Margaret Boden, and she defines creativity as the ability to come up with ideas and artifacts that are new, surprising, and valuable. So it means we have three qualities here. And actually, we can say all of them are very, very challenging to estimate in context of AI. The novelty maybe is the easiest one, because when we create something with AI, we can just check the data set and the training set and see if a particular result exists there or not. And if not, we can say, okay, AI was able to generate something new. But this is a very naive approach, because it doesn't tell us if the result doesn't exist somewhere else, or whether it's not even known to everybody. Value is much more difficult to estimate, because the question is, how can we estimate the value of the creative output? We all know from artworks and creative ideas that have been highly underestimated at the time of their creation. And furthermore, whether something is surprising or not also depends on our subjective opinion, actually, because something that is surprising to me is not necessarily also surprising to you. The technical background of AI and how AI creative systems work actually depends on the very primitive assumption that we limit creativity as creation of data from a finite set of possibilities. For example, if you use AI systems to create text, so the possibilities you have are the words. So you have a dictionary of all possible words, and you can use the dictionary to generate and create new combinations of them. But this is not creativity in a brighter sense, as we see creativity in our daily life. And the assumption or the motivation behind all these systems is that if we have a system that is able to create data, to create new data that is similar to the data in the training set, the system must have learned some kind of essential understanding of the data, because otherwise it wouldn't be possible, right? If we have a system that is able to generate text, the system must have learned something about the words, about the grammar, about the language, and also in that case about our worlds, because language also reflects our worlds, our human world, because we have all these objects, all these relationships between the objects and ideas in the language reflected. But if your system can create or compose music, we can say the same. So the system must have learned something about music. And the idea is that because these systems are trained with large amount of example data, so they very likely would learn dependencies and relationships in the data that we as human observers may not have been aware of. And by doing that, these systems could ideally be able to generate new, valuable, surprising, and actually a data that is valuable because it is new if we are not aware of it, and it is surprising because this is something that we were not aware of it, and therefore this is new to us, and it could surprise us. So this is the ideal case of using the systems. Creation, but also this system could serve us as a new source of inspiration for our own creativity, because again, in the ideal case, we have results from the AI that uses some dependencies and relationships in the data that we are not aware of. And the AI systems always are trained with a particular task. And this task could be, for example, to generate text or image or music. I'm talking about training, so how we train and how we teach AI systems about our data. And we always need a task. And this task often is done by reproduction or imitation. Maybe it reminds you on Alan Turing imitation game. It's very similar also here. So we are not talking about imitation of behavior here, of course, but imitation of data. So it means during the training, AI should learn to reproduce the input as its output. But you may ask, what is the use of it? What is the sense of it? Because AI could actually just copy the input to the output and it would be perfect, right? But the trick is that because of the architecture AI has, it is forced to only use the statistical patterns of the data. It is not possible to copy the data from the input to the output. We have several masks in the system and other mechanisms that avoid that. And the idea is if the AI is able to reproduce the input, it must have learned essential understanding of the data and the rules that the data is created with. And but let's see how this task, for example, could apply to text generation. The standard task to train text generation systems is simply to learn to predict the next word given all previous words in the document, based on the previous context, of course. So it means we at each step we have a document as input, and we want to regenerate exactly the same document as our output. But in each sub-step, the task of the AI is simply to predict the next word given all the previous words in the document. Let me give you an example of that. Imagine we have a document starting with the word today. So this is the only context we have. And there are many possibilities how this document could continue, right? One of them would be today I. Now we know a bit more because we know somebody is talking about him or herself, and this is at least more information though. I am. This is the next word. So the word am is actually very interesting here because after each word, based on the context and based on the rules of the grammar, we have also some limitations, which is good for AI. Because in this case, after the word I, it is actually wrong if I said today I has. This is just wrong, and it hasn't anything to do with the meaning of the context or of the document, but it's just this is just defined by the rules of the grammar. Today I am. What could be the next word? So we have different possibilities, but one of them is, of course, going, because the word going very often comes after the word am. And I think the next word has to be to. So I am going to. This is also a very commonly used phrase. But you see, still we don't have any context. So we are just know, okay, this is about today, it is about I, and I'm just telling you something that I will do in the future. In the cases, so this is during the training, how AI learns. And by mistakes and success, it learns how to predict the next word. But during the generation, AI just simply select one of the possibilities. So it means, for example, here, so we have many possibilities, because I could say I'm going to swim, or I am going to to sleep or to school. But there are many possibilities, all of them are correct. And at the time, during the generation, what AI does is just to select one of the possibilities randomly, based on the probability, of course. But here we have, I am going to talk. Okay, so this is, again, we know more, but I think the next word would be crucial, because I am going to talk, about, this is actually something that we could expect, because I'm going to talk, or we could also say, I am going to talk to, it would also be possible. But here we have, I am going to talk about, but this is I think the most important keyword, because it defines the context of the document. And again, imagine you are an AI system at the time of generation, and you can just choose one of the possible words here and continue your documents. For example, it could be, I'm going to talk about flowers. The context is more clear. So this is how AI creativity actually works. So we have a bunch of rules that are learned during the training, but we have also a huge use of randomness, because AI has no intention to tell you a story or to create a story. So at the end of the day, it has to choose one of the possibilities randomly. Of course, it would be a bit different if you have translation systems, but translation systems, I'm not defining them or seeing them as creative systems, because in those cases, your output has to fulfill some meaning that comes from the source language. In the case of language, it is also important to mention that language is actually really, really challenging because, of course, we have the words and we can, so the words are finite and we don't have so many words and we don't need so many words. We could even limit the size of our dictionary. But language actually reflects our daily life. So as I mentioned it before, so with all its relations and complexities. And this is exactly where AI models come to their limitations, because they only can learn the statistical patterns of the data. And it is not always consistent with the meaning. Even if it is correct, it hasn't any meaning in a sense that it was an intended meaning. So the next example is about music generation. And we have actually a very similar situation also here. We can, first of all, we can represent music as a one-dimensional sequence of data and can train AI systems in a very similar way to the language. And just instead of words, you can imagine we have musical notes, or to be more precise, musical tokens. And the idea, the assumption in background is, again, if we have a system that is able to predict the next note given all the previous notes, so the system must have learned something about music, including music theory and how music is able to trigger emotional responses in us, and even things that we don't know about music ourselves, because music theory doesn't explain really why and how music works. And it's a very similar assumption to the language. And once the model is trained, we can use it to create new similar data, of course. So this is the goal of and the ideal outcome of the model. But let me show you an example of such a system that we are developing and using at Ars Electronica Future Lab. It was mentioned before, it is called Nichran, and it is an interactive AI-based music composition system that we also have been using to create music and performing in different technical demos and projects and performances. And I will show you an example of its creations at the end of the talk anyway. But the question is, if we have a model, if this model is able to create music that sounds natural, emotional, and can trigger emotional responses in us, and we know, according to our audience feedback, that in the most of the cases, it's not even possible for the audience to say if the music was composed by a human composer or by AI or together. So it's not possible to say that. We know that because it's correct in sense of music theory and also other aspects. But again, the question is, where come those emotions? Because we all know these systems are just statistical machines. They don't have any ideas about our world, about our happiness, joy, pain, all these things that we combine with our human beings or our human existence. And the question is, how can AI knows that? And of course, it's based on the statistical patterns of the data, but the AI doesn't really feel those emotions. And the question is, can we nonetheless then say this is meaningful, but what AI can create here? And can we call it art? Because just because something is correct doesn't mean that it has a meaning. And if we call it art, how can we define the value in it and surprise in it? Because the result might be surprising, of course, because randomness is sometimes also surprising, right? And but most of the decisions, the creative decisions of the model are made on a very local level, actually here, because the model is just thinking about what is the probability of the next word, or in our case, the next note, and based on that probability, the context will be created. Maybe this is also interesting to think about in the context of language again, because as we saw at the beginning, we don't have any context, and we just begin to calculate the probability of the next word. And as soon as we have the next word, we have a bit more of context. And then again, we can randomly choose the next word, and the context is even more stronger. And at the end of the day, we get a document from AI that is consistent, because it it is correct. So ideally it is correct, and it has a meaning because everything fit together. And we actually have the illusion that it is intended, that AI was intended to share a story with us. But actually the decisions of the model are all made on a very local level. So just the next word given the previous words. And it is now how we human beings actually talk or generate music. In the context of art, is also the very important question is it a new type of imitation game? Because in the context of art, the newness, the novelty of the result is very, very important. And we all know AI systems are trained with existing data to create new similar data. So the question is, can we go beyond imitation and generate entirely new data out of the imitation task that we have? Because it turned out that this task is very good and very effective to train and to teach AI systems about a particular data domain. But now I'm coming to the next point, which is, in my opinion, the most important limitation for AI creativity, and especially in the light of art. And this is about intention, because intention is crucial for any kind of creation. And we always need intention to create or even to do something. When I am talking to you, I have the intention to exchange ideas and thoughts with you, of course. And I'm not choosing my next words based on their probabilities, of course. And because I have the intention, I have the idea, what would my next sentence be? And based on my intention, I choose my next word. And this is something that we don't have in the field of AI. And to create meaning, we always need the intention to create, and we should actually look at the future. So it means if I am by choosing my next word, actually I'm looking to the future. What am I going to tell you, and what is the stance of my my sentence, and not backwards like AI does in this case. And this is still, we can say that there is actually no AI created artwork without human involvement yet, and I also believe in the future. Because just imagine, as soon as an artist decides to create an artwork with AI and chooses an AI model and selects and shares a particular result with the public, so we have different steps there, and all of those steps are optional. So then we can say it is an intended artwork and not entirely generated or created by AI, because there are many decisions that human had made here. But the involvement of humans, of course, could be at different levels. For example, the conceptual level would be choosing an AI system and creating new data and sharing with the public and selecting, of course, one of the results. But it could also be at data level. This is how Richard Carr, for example, works. So, of course, we have the conceptual level anyway, but at data level, it is possible to use the system, and to influence the output of the system. But if we agree that intention is important in the field of creative AI, the next question is, how can we share our intention with AI? Because we all know AI systems are highly complex systems, and they have millions and billions of parameters, and we don't really know what the contribution of a single parameter is to the output. And therefore, it is no simple way to collaborate with AI systems yet. Of course, it's ongoing research. There are some ideas, but none of them is, for example, in the field of music generation, good enough for really sharing your intention with AI. And the next question, which is a bit paradoxical, is the question of autonomy, because AI systems somehow lack, AI somehow acts like autonomous agents. It means we can really predict the behavior of AI system. And if you think about this in the context of classical tools, commonly used tools like MaxMSP or ProLogic or Photoshop, so you will see the difference. When I use MaxMSP or Logic Pro and apply a low-pass filter to my audio file, so I have a quite good understanding and expectation of the result and how the result will be. because even if I don't know how the algorithm is implemented in the background. But when it comes to AI, we have the problem that AI acts somehow like an autonomous agent. It is, of course, related to the fact that they are not explainable, and we can, we can build them in a way that they have more interaction possibilities. But nonetheless, we can say that most of the decisions, creative decisions in AI systems are done autonomously. And this is interesting, especially in the field of AI and creativity, because if we want the autonomy is one of the characteristics of intelligent systems. But on the other hand, if you're an artist and you want to generate something with AI, so the question is how much autonomy is useful actually here? Or because otherwise, the question would appear that who is the creator of the output? Is it only AI? Is it only human? And the question of autonomy is actually very crucial to answer that question. But we can actually get rid of all these questions if we define AI creativity not in the light of creation, but exploration. So this is about seeing, once the AI system is trained, finished, and a training is done, the output of the AI system is a set of weights and biases. And we can actually use this set of weights and biases to explore new creative ideas with humans. So it means we can try different paths for a particular musical idea, for a melody or theme, and then see what the creative potential of that theme is. And now it is very clear what our role as humans is, because AI is just a tool to give us these exploration possibilities, but in a very, very high level creative way. And we as humans can use this exploration space to have a new perspective on our own data. And also it gives also us a new perspective on our human art, because these systems are obviously, or will be obviously, able to create art and to understand what are the essential features of art to create similar, for example, pieces of music like in dataset. And it also could give us new perspective on our human perception of art, because we will ask us if a machine is able to give us art or music where we can't say if it was generated by machines or by humans. So of course the machine has also learned something about our perception of art. And at the end, I think it will give us new ways of creating art for professional artists and also for non-professional alike, because we can just use this exploration space as our creative space, just to, if you have an idea, for example, a musical theme, or you have a musical idea, musical structure, you can just explore the possibilities of that. So I would like to end my presentation with a short video of a performance we just published. The music is composed by Richard Carr, of course, in collaboration with humans. And the performance is also a collaboration of human, a piano player, actually me, and a self-playing piano. But before that, I really would like to also to mention the name of Richard Carr and the origin of it, because it's Italian, and in its Italian origin, Richard Carr means to search out. But it also refers to a musical form of Baroque and Renaissance periods. And composers used this term at that time when they were searching for the musical potential of a given theme or melody. And this is exactly how we use Richard Carr in our work, just to explore the musical idea of a theme or musical structure. So I am afraid I didn't check the options to share audio with you. So maybe I have to, you can hear anything, right? So maybe I have to just stop my sharing. So the sharing should be stopped. Maybe I can just. Okay, now I have this. Thank you very much. That's my last slide.
Thank you so much, Ali. So just a quick reminder to everyone, this is now the roundtable Q&A session. So you can either type your questions into the chat box and we'll read them out, or you can use the raise hand function and we'll unmute you when it's your turn. So if you have any questions, please feel free to start asking them. So why don't I start off with a question, Ali, since you just played us that lovely piece of music. You mentioned how music and art in general as well, for people, it's something that's deeply personal. It comes from a place of emotion. So can you tell us how have people responded to your artwork, to this music actually specifically, about being moved by something that's made from something that cannot be moved? Was that too complicated?
No, this is a very good question. And I have to admit, I still have the same problem, because sometimes I generate something with AI and this is moving me and I exactly know how primitive actually the system is. So it is just, a bunch of matrix multiplication in it, and it's confusing. I have to say that.
Have you heard much feedback from people about how, do people find it strange to feel moved by something that cannot itself be moved?
Yes, of course. So the first question is, the first impression is, of course, because it's fascinating that a machine is able to create emotional responses in you. But on the other hand, people react differently to the output, because some of them are a bit, scared, because it shows us how manipulative we are, how manipulative AI can be. Because if it is able already to, manipulate our emotions, of course, it could be also dangerous. But others, generally artists, I think they are impressed by that, and they are looking forward to, for the future, so to speak, to use this kind of system to, to come to new ideas and to, they have, of course, they are not going to use this, to use the output as it is. So they have other ideas how to, to use the output conceptually and maybe combine it with different kind of, instruments, music, and, or even they could also, I had an idea from somebody who wanted to take the output and actually play everything else than AI created. So to make crazy stuff, so to speak, with the output, because it is the power of human creativity actually. That it's not necessary to use the the output of AI as it is. We can also manipulate it and use it in completely different ways, and also to manipulate the inner structure of the AI, for example. But at the end of the day, I think it is not scary, because it's just a tool to explore the musical universe we already have. It was made during several centuries, and to just discover new spaces, new positions, so to speak, in this universe, and the emotions and what we have in there. The ability of this music is not coming from AI, of course. It is something that AI has learned through the data it was trained with, and this data, of course, was created by humans. So there is nothing scary in that, but it is something new for us, and maybe this is the scary thing about this.
So you mentioned intention as well. So then why does intention matter if the viewer or listener is moved by that artwork or music piece?
I think the first problem is this is not even possible to get rid of intention, because I composed this piece with AI and I choose the selection, I choose one of the AI outcomes, and I played it and I share it with the audience. So there are a lot of, so to speak, my intention in that. So it's not possible to do anything without any intention, because in that case you wouldn't have any audiences to listen to that. But intention is important because so this is exactly the question. I haven't answered the question during my talk because I don't have an answer for that. The question is intent. The difference between humans creation and AI creation is, as humans, we always look to the future, and I have a plan what I'm going to say. And based on my plan, my intention, what I'm going to say, I choose my words. But in case of AI, music generation or text generation, it's always backward, because you generate the next word based on the context you already have, but you don't have any plan for the future. So this is the difference. And we can, the meaning, the question is, the end document, the result will have a kind of meaning, of course, because it's consistent in itself, and it is correct in terms of grammar or music theory. But nonetheless, the question is this meaning something that we really define as meaning, because it comes at the end of the day out of randomness? So this is the question, and I can't answer that question.
Yes, of course. Brilliant. Okay, so we have a question from Ellen Bao in the audience. She apparently has failed video function, so I shall ask her question for her. And this is a question for Alexander. Ellen says, we may be able to empty our thoughts in meditation. For example, in transcendental meditation, practitioners can go deep into the consciousness, transcending to a space of positivity deep under the surface and abundance, where we can share the consciousness with the origin of everything. And in her view, transcendental meditation sees the brain as a radiator and receptor, and it is a tool for bringing a human being to surpass individuality and make humanity a total being. Would you want this kind of future? And would that be a nice way to learn and practice meditation together in our garden of thought? Is Ellen's question to you, Alexander.
Unmuten. No, I like the thinking very much, because if you look at these Fermi Paradox, why there are no aliens? Because they are seen as a total technological path, only technological progress, and then brings them to space, and everything is technology. But on the other hand, if you look at your suggestion to go deep into ourselves, yeah, and learn about our, yeah, or the deep self, the time from timeline or deep self, then it would be a different path in the civilization, and then they need no, would be a solution for the Fermi Paradox. Would be a happy one, yeah. So we can live. I like that very much. I thought when I didn't mention that, but if you have this meditation, that there are many techniques because people wanted, they felt that there are many, and there are many ancient beings creating their or influencing their mind, this garden, and trying to contact them like that. And I think this one is surely a good technique. I like that thinking. Thank you.
And what about Phil and Ali? How do you feel about Ellen's comment about this?
Yeah, I mean, I was taking down a lot of notes during Alex's presentation, not so many during Ali's, because I thought he was having a lot of interesting points about, yeah, like these kind of like different minds of consciousness. I was wondering, if you take like drama theory, stage theory, it's like we also play different roles, right? We play right
Take
now.
It from what? From what? I didn't understand.
I think like drama theory, Kaufman or something. It's like in the 50s, right? We are like right now presenters in front of the stage, right? But after this soon, we're gonna change our clothes and drink a beer or relax, right? And then later with our family, we play different roles, right?
Roles, yeah.
So
yeah.
Where's the distinction between like using different minds or having different minds in our brain or body, or acting out these minds as roles, right? So I had to think of drama theory, for example.
Yeah.
Right?
There
was
another
front stage
middle.
with people, there's the backstage, there's the offstage, you're alone.
Yeah, there's another
where you like eat and you burp and you fart, for example, because nobody's around. You are a different person. So
yeah, there's another metaphor fitting your stage image, your stage metaphor. It's coming from neuroscience, and I think it was this Christoph, and he said your mind is like a actor's play, yeah, and you're watching from above, and you don't know what they're doing. And when you switch the light on, it's in the dark, yeah. When you switch the light on, everybody isn't moving anymore, like that. Yeah, so that was a stage metaphor from the neuroscientist to say, okay, these different actors are always in motion, and there are experiments, for example, problem solving. If you most successful problem solving is to get all the facts and then do something else, yeah, and then somebody in there, yeah, I think some little demons are solving the task for you. If you are thinking straight, on the other hand, focused, then this will only work if the problem, if the path to solve the problem is clear. Yeah. If the path is not clear, that's a creativity thing from Ali too. Yeah. If the path is not clear, then these little minds do it on their own. Best if you not disturb them. That's this experimental proven. Fascinating too.
Should I continue?
Sure, yes, go ahead.
Yeah, I just wanted to add something because I mean, I really like the very inspiring talks and questions here. So what I wanted to add is by using AI, I really think it is fascinating to learn something about ourselves, because if we have the AI, the AI can learn us more about ourselves. And in this case, the question is, in this context, if we are not even able to communicate with our own mind, because our unconsciousness, and so how can we expect to communicate with AI? And I mean, AI, it's not an agent, or it's not a person, of course. We are talking about a bunch of matrix multiplication or something like this, but nonetheless, it reminds me very much on our unconsciousness, or Daniel Kahneman would call it maybe a system 2. So this is where we can really communicate with it, but we know it has learned something is there. So this is a fascinating thing. If you use AI to create text or music, you see, okay, this thing has learned many things about music that are fascinating. But how can you communicate with this? So it's maybe just like our unconsciousness, because we can't communicate with it through words, through concepts, but indirectly maybe. So
I would frame it as a mirror of your past work. Yeah, you have fed it with old data from your past work, so it's your past, and now your past is working, and it works like a mirror. But you, of course, you have developed in time. Yeah, the data not. So the AI system is a mirror of you, is mirroring yourself as it was in time. I'm waiting on an AI system for mirroring myself. Yeah, as a psychological tool for development. Yeah, for example, there was an art experiment about some guy, and he made a chatbot in a chat program and trained it with his own chats, and the chatbot then first said only yeah, and then his friend said, okay, that's you. Yeah, so
the question now
mirror.
I want to pose to Ali and also Alex and the rest, of course, is what happens when the AI system we collaborate with, or which supports us based on our training sets or whatever, outscales us, right? So if the AI system generates better music than you can create, Ali. And when do humans engage with an AI system? I want to study music, I want to learn to play the piano. Would you recommend me to start with an AI-supported system to learn to play the piano? This is, I think, where it gets interesting. And I have personal opinions about that, right? Which are disconnected from, like, my research and what I find, but I'm going to stipulate it. I read like this overly, if we all sit in driving cars, okay? Some point in time, we won't be able to steer a car manually, right? If we all use microwaves and put food in and push a button, we won't know how to peel a potato and boil water. We might be able to relearn that, admittingly. We might be able to adapt. But how would you feel like, if that AI composes music which exceeds your capabilities, and what would you do with it? Would you then give the AI an identity, Ali, publish the music as like, created by that entity because it didn't come from you?
What do you say, Ali? I think in my case, I wouldn't say AI composes music, it rearranges, and you need somebody who gives it a fresh kick, or Ali is a professional for that question.
Yeah, I mean, it is, I think if you use AI system to explore again, to explore the musical heritage we have from last centuries, and you have, for example, you have a musical idea. It can be several notes or musical structure, and you fit the AI that idea, and it gives you many examples that are really good, from the musical point of view. And of course, at the end of the day, it is you that chooses one of the pieces. Of course, capabilities is another thing, because sometimes they are really better than what I could, for example, compose, right? But yeah, I don't know, maybe, there are many capabilities in our daily life that we don't have anymore. So I am also not so fast in running, for example, and can use machines to be fast. But at the end of the day, it is important to fulfill my intention. So if I have a expectation, I have an imagination of a particular piece of music, and I can AI to go there. So I think it is fine. And on the other hand, we are talking about, we are not talking about a particular person like me, but we are talking about how can AI be useful, for a brighter community. And I think in that case, so AI can help us, to democratize music, also to get new ideas from this musical universe, so to speak. And what I also see for the future, this is a bit a problem that we have traditionally, because we always think in music until now in a set of pieces. We always talk about musical pieces, but maybe this is something that will change in future, because if it is not anymore about pieces, if we imagine music as a space of possibilities and how we can go to different paths, so the same piece would exist in endlessly variations. So because you have, a piece is represented as a position in this multidimensional space. And if you go around this space, this position, so you will get the same piece again and again, but every time different. And you can also transform this piece to another piece that is far away. So I think we will think about music in some years or decades differently, not in as a set of pieces, but as a space. And in that case, I mean, it's also not important or who the composer is actually, because it's more about the space there.
It's more about
how
itself.
we explore it. Yeah, exactly.
Yeah, but another thing, as a social scientist, I have to warn you about this AI stuff, because it is old data, the training data, and you cannot fetch one piece and pull it out, selectively. This is in the numbers in there. And if you think of an AI and its statistics, so think of an AI system made when the Earth was flat. This AI system would always correct this one who writes the Earth is round. Would be an error, just an error, nothing else. So it's a conservation of old and sometimes outmoded or really wrong or racist data. You can't. The problem is you have to renew it completely, which is a very large effort. And so I'm skeptical that people are doing that. So there will be these racist stuff, and all this will just stay. Otherwise you have to throw away everything and retrain the thing. That's from a social perspective or cultural perspective dangerous.
It's true what you say. I just want to support that. Maybe like music, I'm not the music expert, Ali, but I guess it's highly mathematical, right? It's like symmetrical and stuff like this. So maybe it caters toward like AI supported recomposing with a set of training sets. I know there's literature which has been written up to the 8th or 9th grade by AI, which you can differentiate from a human author. Is there right or wrong music? That's hard. It's a creative space, but maybe like in other areas of application, it's like a little bit more differentiatable, as Alex was indicating with a flat Earth example, right? Or like a racial bias. Support systems.
You have to see that bias is the wrong word, because it's not that's the technology in itself is biased, because it's based on data which were written by men. And so it's included all the time. You cannot de-bias AI. It's with the same task to de-bias society. It's impossible. But it's but I would think it's a very fine as a mirror. It's a mirror of behavior, for example. Because it produces patterns. It's not finding patterns, but it's producing patterns. It's a difference too.
And this is a really good point to come back to what Phil was saying earlier about using sci-fi as a tool for ethics education, for example, or at least a discourse, which seems to be what the world seems to be lacking, really. Like, our technological development has gone so far ahead compared with people who are sitting there thinking about, should we be doing this, or should we be doing this in this way? The technology can, but should we? And so that's a big question there. Phil, do you want to say something? We don't have too much time, but if you guys are okay to overrun a little bit, we did start a little bit later, so we can keep chatting for a little bit.
Very basic question, the ethics, because if you show technicians the movie Avatar, they are fascinated by the killing robots. They want to build kill robots. Or Minority Report, they want to build. What's Jordan? Philip? What do you tell about that? Because these people have different perspectives on dystopian stuff. They like it.
I mean, it's always like, climate change doesn't matter if it's not in your backyard. Okay, if like your house is not flooded, but you like Alex, you don't watch TV, I guess, but you don't read about, you know, it's a human, there's also this human nature, you know, which is like kind of like intrinsic to all of us. So I recall when I was young, I watched like Terminator 2. I must have been at the time 10 or 9. I was scared. I was shit scared of like the Terminator. That like, you know, I kind of like created my imagination of robots, you know, as a very dystopian, negative thing. And now, like, you know, of course, like, kind of like amplifying that point of view is like, you know, I never saw a robot. I had no idea, but like, oh, there's robots, machines, and they can like do stuff in that regard, something really bad, like humans or mankind. But of course, like I tried to indicate, I mean, it's a nice use case just to look at it. You can even go further, right? So they did stuff like in the area of research I'm engaged in, they put out real job ads as research studies, which were for fictional jobs, okay? Jobs of the future, right? So like AI maintenance machinist or something like this. And then we're just like looking at people who applied for these jobs, right? So the science fiction, the whole like area, it allows, it's kind of like a lab, you know, it allows to some degree to like explore possible futures, to see how things could turn out. And this Outbreak in 1993, you know, it's a science fiction movie with Dustin Hoffman with like, you know, the virus, everybody wears like masks and like protective suits. It's basically the story of like COVID to a large degree. So it's there. And I think it has to be, I don't want to say pushed more, but visibility has to be increased in STEM, in hardcore sciences, right? I don't know how much, like, you know, AI engineers care about that, you know, or about the singularity, or about what will be done with their algorithms, you know? They maybe only care about the technical aspects. There's this huge movement right now toward like explainable AI, you know? It's basically like the recourse of nobody understands anymore what's going on. You cannot like, you know, explain it like to the everyday person why the system is doing that. So there's like this,
yeah, because it's statistics. You cannot explain the point of statistics. That's technical. It's the idea of explanation is wrong because there are no semantics. If you want to have semantics from an AI system, from a machine learning based system, then you are on a totally wrong path. There are no semantics.
But yeah, I'm talking about like general public, right?
Yeah.
So I'm not talking about like the, you know, the group of select people of us here in the Zoom room, right? Because as this technology socially becomes pervasive, right? It's like people, normal people need to understand it as well, right? So
and maybe
yeah.
another point to, I think the explainable AI, it's not only important from an ethical point of view to know why AI decides for something, for a particular result, but also the hope is that if we have explainable systems, maybe we can communicate better with them, because then we know how they work, and where we can, you know, change some parameters to, you know, to communicate our intention with AI. So this is another the other motivation behind having explainable
we would
AI.
need to find then the examples which were given into the machinery to train it, and then we have the culprit to see this guy, he did it. And that was what was a social explanation of a decision, then of a decision which is maybe wrong or questionable. But you have to find the guy or the guys or the companies who fed the algorithms. I think this is nearly unexplainable.
You can go into details, but let's to go back to like, you know, the initial prompt for me or something like this just poses a general question, like would you, like, you know, you give your kid or your baby into the care of a robot nurse or caretaker, you know, like regardless like what training set was programmed into that, you know what I'm saying? Just like the general point of view that like AI or these kind of autonomous systems take over at some point. So I think that like, yeah, science
it's automation problem is automation and with a loss of knowledge, practical
knowledge. That's what I tried to say earlier, right? When I mentioned that like we will lose the ability to cook food.
Yeah, you cannot make your food. That's even worse. Thing of climate change, and you're not able to plant some food. Plant your food.
I want to share this, for example. I was teaching one class in social informatics, And I had an extra credit assignment for my students. Everybody should do this. Go offline for 2 hours, 2 days, fully. Only cash, no cards, no social media, landline phone only, and cash. Some of my students did it. I had to come back and report about the experience. They said like people were like worried, they were dead, they were like missing, you know, like they were so like, they didn't know what to do as well. They felt anxiety, you know? So like it really like showed this like dependence on these systems and this like loss of orientation and I don't know, I'm exaggerating now, but like, you know, purpose. If suddenly like we had the Facebook outage, when was it? Like 3 weeks ago. And you know, like it was like the planet stopped rotating or something like this for 2 hours.
The more worrying thing is that people know that they are dependent, but they cannot. Like there's a growing number of people who are voicing their anger at what Mark Zuckerberg and his company is doing to the world, and yet they are still unable to detach themselves from their platforms that they're using.
That's part based in evolution. When we are these tribes, these 100 people, yeah, then news were most important. Bad news to avoid fall into a hole, something like that. So the people were always, we have antennas all the time to hear bad news because they were useful to us. Yeah. Then with these 100 people, maybe in the tribe, in the jungle or whatsoever, that was very useful and was important. So we have ears like that, and we will tell them the others. But now we hear about accidents in Siberia, yeah, and they are totally not useful for us. But we cannot. It's very difficult. So we have to unlearn evolutionary traits. You understand? We have to unlearn some stuff like this. What I said. These. If there is a problem, walk away like that. It's not possible. And every news, listen to every bad news and tell them the other people immediately. Yeah, that's a bad thing. That was very useful 40,000 years ago. And now the companies are playing with that, with these evolutionary forces in us.
Yes, and perhaps this is a good time to say that we can come back to Ellen Pau's suggestion of meditation and perhaps everyone just slowing down a little bit, doing Phil's experiment where we go offline for a wee while, but maybe tell your friends and family that you're not dead, that you're doing an experiment before you do that, and see how it goes. And maybe we'll just be able to give ourselves a better future then, hey? All right, well, a big thank you for Ali, Alexander, and Phil for sharing your research and insights with us. And also, thank you so much to all the participants joining us this evening. Before we go, I do want to make sure you all know we also have the MIT Media Lab and Microwave Online Seminar tomorrow's on Thursday, the 11th of November at 9 p.m. Hong Kong time. There'll be 3 members of the MIT Media Lab sharing their research projects on deepfake streams and space with us. And so we look forward to having you join us then as well. Thank you so much and see you then perhaps.
Yeah. Thank you. So, thank you
everyone.
Bye.